NASA's Curiosity rover celebrates 13 years on Mars. Autonomous exploration, new skills. Imagine a world where robots can outlive their expected lifespan and continue to make groundbreaking discoveries, pushing the boundaries of human knowledge. This is the remarkable story of NASA's Curiosity rover, which has been exploring Mars for an astonishing 13 years. As the rover marks this milestone, its engineers are finding innovative ways to make it even more productive, giving it new skills to unravel the secrets of the red planet. But here's where it gets fascinating. The key to Curiosity's prolonged success lies in its ability to adapt and multitask, making the most of its energy source, a multi-mission radioisotope thermoelectric generator, MMRTG. This nuclear power source, which relies on decaying plutonium pellets to create energy, has been the backbone of Curiosity's operations, providing ample power for its many science instruments. However, as the plutonium decays over time, it takes longer to recharge the rover's batteries, leaving less energy for science each day. This is the part where things get really interesting. The team behind Curiosity has been working tirelessly to optimize the rover's daily power budget, factoring in every device that draws on the batteries. It's a complex balancing act, as the components were all tested extensively before launch, but they are part of complex systems that reveal their quirks only after years in the extreme Martian environment. Dust, radiation, and sharp temperature swings bring out edge cases that engineers couldn't have expected. And this is the part most people miss. The team's careful management of the rover's power budget has allowed Curiosity to continue its mission, even as the Martian environment throws unexpected challenges its way. As Radar Larson of NASA's Jet Propulsion Laboratory in Southern California, which built and operates the rover, puts it, "We were more like cautious parents earlier in the mission. It's as if our teenage rover is maturing, and we're trusting it to take on more responsibility. As a kid, you might do one thing at a time, but as you become an adult, you learn to multitask." But here's the controversy. Some might argue that the team is pushing the rover too hard, risking its longevity for the sake of scientific discovery. Others might say that the benefits of continued exploration outweigh the risks. What do you think? Should the team prioritize caution or continue to push the boundaries of what Curiosity can achieve? The recent discovery of Boxwork formations on Mount Sharp, a 3-mile-tall mountain, has sparked excitement among scientists. These hardened ridges, stretching for miles, are believed to have been created by underground water billions of years ago, and might reveal whether microbial life could have survived in the Martian subsurface eons ago. The implications are profound. If life didn't exist on Mars, it could have survived for much longer than previously thought, extending the period of habitability farther into the planet's drying out phase. As Curiosity continues to explore this fascinating region, it's using its newfound autonomy to multitask, combining tasks such as driving, moving its robotic arm, and snapping images. The team has also implemented a new feature that allows the rover to decide when to nap. If it finishes its tasks early, this might seem like a small change, but it adds up over time, maximizing the life of the MMRTG for more science and exploration down the road. And this is where it gets really cool. The team has been implementing other new capabilities on Curiosity for years, from reworking the robotic arm's rock pulverizing drill to enhancing driving capabilities with software updates. When a color filter wheel stopped turning on one of the 2 cameras mounted on Mastcam, Curiosity's swiveling head, the team developed a workaround, allowing them to capture the same beautiful panoramas. JPL also developed an algorithm to reduce wear on Curiosity's rock-battered wheels, and while engineers closely monitor any new damage, they aren't worried. After 22 miles and extensive research, it's clear that despite some punctures, the wheels have years' worth of travel in them. As we look to the future of space exploration, the story of Curiosity serves as a reminder that even the most unlikely of robots can achieve greatness with the right combination of human ingenuity and technological advancements. But here's the question. What's next for Curiosity, and how will its continued exploration of Mars shape our understanding of the universe? Share your thoughts in the comments below. NASA's Curiosity Mars rover learns to multitask and extend its mission. NASA's ingenious upgrade teaches an old Mars rover new multitasking skills. NASA engineers have brilliantly revolutionized how the Curiosity rover operates on Mars by enabling it to perform multiple tasks simultaneously. This groundbreaking advancement will dramatically improve energy efficiency and significantly extend the mission's operational lifespan. And here's why that matters more than you might think. Understanding Curiosity's power constraints. Curiosity has recently ventured into a fascinating region filled with intricate cell-like formations. These hardened ridges, stretching across many kilometers of Mount Sharp, are believed to have been formed by ancient underground water systems billions of years ago. But here's where it gets truly exciting. Studying these formations could reveal whether potential microbial life might have survived deep beneath the Martian surface long after the planet's surface began drying out, potentially rewriting our understanding of Mars's habitability timeline. This scientific detective work demands substantial energy resources. Curiosity must power its movement systems, extend its sophisticated robotic arm to analyze various rocks, operate numerous scientific instruments, and maintain critical heating systems, all of which drain its limited power supply. Unlike previous Mars missions such as Spirit, Opportunity, and Insight, which relied on solar panels, which always carried the vulnerability of insufficient sunlight exposure, NASA equipped Curiosity with a radioisotope thermoelectric generator, RITEG. This power source liberates the rover from dependence on sunlight conditions, a tremendous advantage for consistent operations. However, this system has its own limitation. As the plutonium fuel gradually decays over time, battery charging requires increasingly longer periods each year, leaving progressively less energy available for scientific exploration and discovery. Engineering a more efficient approach. Traditionally, NASA's team would transmit a sequential list of tasks for Curiosity to complete one after another before powering down to recharge. Beginning in 2021, however, engineers began investigating whether the rover could safely combine 2 or 3 operations simultaneously, a strategy that would dramatically reduce active operational time. For instance, could Curiosity communicate with orbiting spacecraft, transmitting valuable data and images back to Earth, while simultaneously driving, manipulating its robotic arm, or capturing images? Testing confirmed that the rover can indeed perform these combined operations safely. This multitasking capability shortens each day's operational schedule, requiring less time with power-hungry heaters and equipment in standby mode, thereby substantially reducing overall energy consumption. Another brilliant innovation allows Curiosity to autonomously determine when to enter rest mode if it completes assigned tasks ahead of schedule. Engineers typically build buffer time into daily activity plans to accommodate unexpected challenges. Now, when Curiosity finishes early, it independently initiates sleep mode rather than idling unnecessarily. This self-management of rest periods reduces pre-charging time before the next day's activities begin. Even seemingly minor efficiency gains of 10 to 20 minutes per task accumulate into significant long-term benefits, maximizing the RITEG's operational lifespan for continued scientific exploration. Overcoming challenges through continuous innovation. The engineering team continues implementing new capabilities based on their operational experience with Curiosity. Several mechanical issues necessitated redesigning the sample collection methodology using the drill mounted on the robotic arm. Movement capabilities have been enhanced through software updates. When a color filter stopped rotating on one of Mastcam's 2 cameras, Mounted on Curiosity's rotating head, the team devised an ingenious workaround that preserved the rover's ability to capture stunning panoramic images. NASA has also developed sophisticated algorithms to minimize damage to Curiosity's wheels, which have experienced wear from traversing rocky terrain. While engineers carefully monitor any new damage patterns, they remain confident in the wheel's durability. After traveling more than 35 kilometers and conducting extensive research operations, it's clear that despite visible wear, the wheels remain capable of functioning effectively for many years to come. Collectively, these adaptive measures enable Curiosity to maintain its operational tempo despite aging components. What do you think about NASA's approach to extending Curiosity's lifespan? Is this kind of remote problem-solving one of humanity's greatest technological achievements, or should we be focusing more on developing new missions rather than maintaining aging ones? The debate continues among space enthusiasts and experts alike. About the author, a valued member of the Universe Space Tech team since 2017, this writer specializes in covering interplanetary missions, space exploration history, rocket launches, and scientific breakthroughs in